Hello, lovely humans, Jen Foxbot here. In today's episode of Math Mondays, we are going to learn about the inverse square law. So, what is it? How do we read it? And what the heck does it mean? So, inverse square law is full of some math jargon. Let's look at it one word at a time. Inverse means opposite, and in math speak, that typically means a fraction. Square means to square something, or to take a number and multiply it by itself or raise it to the power of 2. And law just means a rule. Oftentimes when we talk about the inverse square law, we are talking about things like gravity or electrostatics, which follow this pattern. So let's actually look at what this pattern is. The inverse square law says that some number y is proportional to the inverse square of some other number. And in science, typically what we're talking about is the intensity of, let's say, the force of gravity is proportional to 1 over the distance squared. Because it's this inverse square law. You gotta have that square right there. So for example, the gravitational force, the strength of the gravitational force is proportional to 1 over the distance squared. In electrostatics, the electric force is between 2 charges is also proportional to 1 over the distance squared. So very quickly, what this means is that the closer you are, the stronger the force is. The farther away, the weaker the force is. Okay, but this is math. How much are we talking about? Let's actually quantify this. I'm glad you asked. Okay, so what I love to do is draw pictures. So an easy way to do this, or a lazy way to do this, which is what I like to do, is to use a plotting program like R or Python. You also can do this by hand if you're in a hurry. So or on camera. So let's do this by hand. We're going to make a table of some representative values. So since y depends on x, we pick x first and we calculate y. If x is 0, 1 divided by 0, what is, we can't do that. That's called undefined, or UND for short, because again, I'm lazy. If x is 1, you have 1 over 1 squared, so y equals 1. If x is 2, you have 1 over 4, so 1/4, or that's a funky 4, or 0.25. If x is 3, you have 1 over 9, so 0.11, ... If x is 4, then you get 1 over 16, which is 0.6, whoopsies, hold on, 0, oh, I almost got ahead of myself here, 0.625, and if x is 5, this will be our last data point. If x is 5, we get 1 over 25, which is 0.04. So then what we do is we take our representative values and we draw a picture of how y changes depending on x. And so if this is y equals 1, I'm going to make my scale a little bit off, a little bit different, but we end up with a plot that looks like this, where the closer you get to y, the closer you get to y, the larger the value is. So the way that we would interpret this is if we have 2 charges. Ooh, let's use a different color. Let's use blue. Let's say we have 2 charges where d is the distance between them. If we decrease d, so x would be d in this case, the smaller the distance is, the larger the force between these 2 charges. But if we increase d, if we go along this line, then y gets very, very small and approaches to 0. And once you get a certain distance away, you can be like, that's pretty much close to 0. You can effectively say it's negligible, which is what physicists love to do. Scientists in general, I would say. They're like, it's not a significant effect on the charges, and so we can ignore it. It does depend on the context of your problem. Context is everything. But in general, at a certain distance away, the force between the two charges approaches zero. Yeah, so that is the inverse square law. Not so bad. Always recommend drawing a representative picture to help you out. Okay, so please let me know if you have any questions about the inverse square law. I'm happy to do a specific example with gravity. We've also done some example problems in electrostatics if you want to check that out. Hey! Okay, so let me know if you have any questions or other math topics you'd like to tackle. Thanks very much for watching, and we'll see you next time. Bye!